Thank you. It's truly an honour to be here in this historic building, speaking today in the footsteps of so many who have spoken here previously to me about the Southern Uplands. For example, Charles Lapworth, who in 1878 worked on the graptolites of the Southern Uplands, and that work eventually led to the Southern Uplands controversy in the 1980s, which has now largely been resolved. I'll talk about that a little bit in a moment. But it provides a firm geological framework in which to investigate the mineralisation, which has been somewhat neglected in comparison to the geology. So, myself and Simon Cuthbert at the University of the West of Scotland have been working on this project funded by Scotia, which is a small gold exploration company. They were interested in exploring for gold in a small village called Lead Hills, where today you'll find a lot of gold panners, and historically it was very productive economically for gold, and the Scottish crown jewels were produced from gold from there. However, the source of the alluvial gold is somewhat of a mystery still. So we have a PhD student working on the superficial deposits, and my interest with this aspect was to try and review the regional picture for gold mineralisation and understand what's going on regionally, what kind of controls on gold mineralisation there are. So we have a handful of gold mineralised localities in bedrock, and you can see there's some significant economic grades. This one in Central Ireland is estimated to contain about 1 million ounces. That's a JORC compliant resource. And it's been classified as an orogenic gold belt. Indeed, it looks pretty typical. It's in an orogenic setting. However, when you look in detail at some of the deposits, we see a varied set of magmatic deposits. For example, here at Terrane, there's a magmatic platinum group element and gold deposit, and there's also comparable magmatic deposits further north in the Highlands. We also see intrusion-related or intrusion-hosted deposits. For example, here, I think, Hare Hill, and porphyry-type deposits here at Blackstockerton Moor and at Burn. And we also see lode-type veins, structurally controlled veins within greywackies. However, all these varied deposits do have very similar characteristics. And I'm going to argue that magmatism was important in controlling gold mineralisation throughout the Southern Uplands terrain, and why this is also important globally in post-subduction and soft collisional settings. And I want to talk about the implications for the long-lived debate on the role of magma in orogenic gold deposits, and in particular debate on sources of fluids and metals. So briefly, the geology. It's part of the Caledonide orogenic belt, which is composed of a whole series of terranes, this being one of them. To the north, we have the Grampian terrane and other terranes that belong to the Eurasian continent. To the south, we have the Avalonian terrane, and they closed up by the Devonian along the Iapetus suture, which runs through here. And the Southern Uplands, the controversy was over its interpretation. It's now largely resolved. It's understood to be an Ordovician subduction accretion complex in the north, and the southern part represents a Silurian fallen fold and thrust belt that was deposited and deformed during that collision. And we see a very low metamorphic grade throughout the terrain. It's prainite, pompelliite facies, so sub-green schist, indicating that it was not deeply buried. It's a soft collision. And we see these plutons throughout the terrain, Newry, Lochdoon, Criffel, and they are part of the trans-suture suite. They have shared characteristics across the suture zone, both to the north and to the south in the lakes terrain. They're zoned calcalcaline plutons with dioritic, I-type, metaluminous, more mafic rims, and younger cores which are granitic, S-type, and pervoluminous. And long ago, it's been recognised that there are regional systematic trends on a larger scale in the magmatism that indicate a subduction influence in the mantle source. So chemical trends perpendicular to the suture zone. These plutons have been dated. Recent dating of zircons using uranium-lead techniques has shown them to be 410 to 416 million years in the case of Fleet and Criffle, and some of them have much younger cores, possibly as young as 387 million years. Lamprifiers throughout the region, particularly in the south, have been dated 400 to 418 million years. And just briefly, the structure of the terrain, it's got a dominant caledoniid, north-east-southwest trending structure that results from thrust imbrication of all the bedding during essentially orthogonal convergence in an accretionary, subduction accretion complex. And then superimposed on that, we see these transverse northwest, southeast, and also north-south strike-slip dominated structures. There's not a lot of strike-slip offset on those structures, but they relate to a slightly later phase of transpression and transtension. So, finally, on to the next slide. Fluid inclusion data then. This is to argue that these things are all related. Here we see the early veins, whether they are from intrusion-related deposits or porphyry types or lodes within metasediments, they all fall within a group of fairly moderate to high temperature and low salinity fluid types, and all these other ones, some of them from the same localities, represent lower temperatures and higher salinities, a later event of lead-zinc mineralisation. But I want to focus on the gold. So, looking at delta 18O and deuterium isotopes, we see essentially the same thing. These early veins falling here within the fields for metamorphic and magmatic type fluids, whether they're from igneous hosted or sedimentary hosted deposits, and then we see the younger veins, again irrespective, but indicating more meteoric type of fluids. In terms of the mineralogy, again, whether they're related to intrusions or not, we see very similar alteration mineralogy and ore mineralogy. And in particular, I want to draw attention to this one from Blackstockerton Moor, which is interpreted as similar to a porphyry deposit, but as evidence for veining and brecciation, hydrostatic explosion kind of structures immediately above a granodiorite sill. So that indicates that the alteration and the mineralisation are all related to the intrusions. I think it's pretty good evidence. We see similar geochemical patterns associated with alteration from many different deposits in the terrain. This is just data from the Clontiburat deposit in Ireland, but it shows that arsenic is the main pathfinder element related to gold, and it increases with potassium, or potassium-sodium ratio. And we can see these profiles across the lode zone where potassium-sodium ratio increases as you approach the lode zone, and the opposite trend reflected with magnesium. But there's also antimony mineralisation, but that seems to be a slightly later stage, and I'm not sure if it relates to the gold or not, but it's superimposed at least. So the anomaly maps, this one for arsenic, and this one for gold, this one for arsenic, this one within granodiorite, intrusion at Hare Hill, and this one within Greywackies, but showing the same structural control. Strangely, perhaps, the dominant control seems to be the caledoniid north-east-southwest, and in drill core, that is only low-grade anomalies. The higher-grade anomalies are within these north-south trends, the transverse structures, which are less evident in the soil geochemistry, and I'm not sure why. So, again, the structures here, poles to veins, dominantly north-south, strike of veins, dominantly the north-south, third phase of deformation. And we can compare this to structural data that shows these are sinistral strike-slip faults throughout the terrain. So the mineralisation is clearly associated with this phase of deformation and magmatism. This is just a sort of block diagram to show the structure This is the colledinoid northeast-southwest trend, and these cross-cutting conjugate sets of strike-slip fractures and faults cut by a pluton. Generally, the plutons post-date all of this, but it's a bit more complex, as we'll see. So in detail, at one of the localities where you've got economic grades of gold, Glen Head, we can see that we've got polyphase hydrothermal activity and mineralisation, and polyphase intrusion, and we can use that to get a bit of an idea of the sequence of things, but it's pretty complex. These are the higher grade veins, and they seem to post-date most of the intrusion and deformation phases, and they're associated with this diorite. So this is part of the early formed, more mafic rim, which is oxidised, and it's I-type mafic rim of one of these large intrusions, and that's what the gold seems to be associated with. So, two maps to compare the metamorphic grade. This is low grade, low antizone, prainite, pompelite facies, just about metamorphic. But I think it compares really nicely with the arsenic anomaly map. The metamorphic grade was initially interpreted by Merriman and Roberts, who did this work, as being a result of the accretionary burial, but I think it looks more like it's related to the plutons and also to a major shear zone through here, the Moniev shear zone. So it looks to me like the mineralisation is related to the metamorphism, and also to the magmatism, and also to the deformation. Where are we up to? Okay, so this is work by Miles, Andrew Miles, showing the timing of granite emplacement from new uranium-lead zircon ages, and it shows quite well that the granite's been in place during a period of transtension. These are the ages of cleavages, transpressional cleavages in England and Wales. So we've got an early stage of lamprified dikes, and then following that, during transtension, the granites come in, and I think gold mineralisation is associated with that. Also, we can say something about magma sources. Again, I think it's Miles' data from 2014. Hafnium isotopes and oxygen isotopes indicate that the magmas were sourced in Avalonian crust or possibly mantle. Oxygen isotope trends, and particularly lead isotope trends, indicate derivation from the Skiddaw, or sediments similar to the Skiddaw group, which is from the Lakesman Terrane, Lake District sediments. So gold is associated with the lamprifiers and the I-type mafics sourced in the Avalonian plate. This is sulfur isotope data from the Southern Uplands. I'm actually going to skip on to this regional sulfur isotope data. So if we look at this, we can see this is the Lake District. The I-type early phases of the plutons, also in the Southern Uplands, sit here within the range for primitive subcrustal melts. However, the more S-type parts of the granites here and here are moved more towards the compositions of the sediments in each terrain. So the Moffat shales, the sedimentary rocks in the Southern Uplands are here. The sedimentary rocks, the Skiddaw slates in the lakes are here. So we can see that it looks like there's been assimilation of those sedimentary units. However, this would seem to contradict what I just said from the isotope evidence from the Southern Uplands that the magmas were sourced in the Skiddaw slates. So I need to go to my notes. So, and if we look at the loads in the sedimentary rocks, that's these ones, they're even more closer to that. This raises a few questions. Was the Skiddaw sulfur lost during sulfur saturation? Even if that was the case, how would sulfur from the Southern Uplands sedimentary units have been assimilated into the magma without picking up some of that signature for the lead isotopes or the hafnium or other signatures in the zircon? That's a problem. I think that actually the data for these are not well constrained in terms of paragenesis. I don't think it's clear that these are magmatic sulfides. I think these are hydrothermal signatures, and that this is hydrothermal hydrothermal interaction of fluids, hydrothermal equilibration with the host rocks, and mixing between possibly magmatic derived fluids and metamorphic fluids. And the metamorphic fluids could have been derived from dehydration during contact metamorphism, and we know that because it's very low grade terrane, that it was fertile in terms of fluid. So that confirms the metamorphic and arsenic maps that they're all related. So model, we see systematic geochemical trends. We know there was a subduction influence in the source region. We know that it was a post-subduction cause of melting because of the ages of the granites. We know that the intrusions straddle the suture zone. So therefore, it can't really have just been simply subduction related. There's no evidence that it was deeply buried, so it's not like an orogenic anatexis. And we know that magmatism was coeval with transtension, so we've got to take all these things into account. And principally, the fact that the intrusions straddle the suture zone is evidence for slab delamination. This is a model adapted from Miles's work and others. So we've got an inherited subduction zone metasomatism in the mantle, giving it fertility. Soft collision causes delamination because it's not forced collision, so the slab's not being forced underwards, and if it's hot and dense, then it has to roll back. This is inherent within soft collision zones. It causes upwelling of the astenosphere, generating lamprophyric melts, heat convection to the lower crust, melting and assimilation. Transtension, which is common in these collision zones, gives us the favourable plumbing system, allowing effective mass transfer to near-surface environments. It's not been deeply buried, and that leads to preservation of deposits. So I would argue that soft collision, post-subduction regions are inherently prospective for gold, and that magma is important because it enables mass transfer to shallow crustal levels. I'm actually going to leave it there because I'm running out of time. Thank you very much.
Thanks, Sam. Excellent talk. Any questions? I think we've got time for one or two. No? Oh.
Can you say something about a bit more about the sources of heavy and light sulfur? So the Skiddaw slates have heavy sulfur, presumably because they have sulfates, they're oxidized. And what about those very light values? Why would you think those would be associated with mixing with hydrothermal fluids?
Well, if these are the primary sulfur isotopes from the sedimentary rocks, then it could, there are various reasons, but I think the favoured one is that it could relate to an open or a closed system where the bacteria are metabolising seawater sulfate, and that can fractionate it one way or the other, depending on whether it's an open or a closed system. I don't know a great deal about it, but I know that's one of several explanations.
Any more questions? I'll let the young man there had his hand up first.
So recently in Geoscientist, there's been an article saying there's not enough money going into British exploration, and certainly no one's doing any worthwhile drilling. Do you think there's anything worth finding there, even if we did go and drill the lead hills?
Yeah, well, I don't know about lead hills, but there's certainly some pretty good indications that are encouraging. Yeah. There's not many companies operating in the Southern Uplands. There's one that I know of looking for gold, but yeah, I think that, why not? Anyone want to place a bet?
Sell the shares in Scott Gold. Yeah, and are they having a good? Are they finding raising the financing relatively straightforward, or is it just?
I don't know. Sorry.
Okay. Any more?
Have you looked at the trace element geochemistry of the rocks in the belt as compared with, say, porphyry copper ore productive magmas? Similarities, differences? What's the difference between an apennite and an adachite in terms of trace element chemistry?
You're putting me on the spot. I'm sorry, I couldn't.
Okay. Well, No, I don't. I actually don't. It's a serious question.
Appanites are related to lamprifiers, as I understand it, so very primitive. Adachite, no, can't remember, sorry. I'm not brilliant with my igneous
Well, my recollection
classification.
is that they're quite enriched in light lithophile, in large lithophile elements.
Adachites,
Appanites.
appanites,
And
right, yeah.
at least superficially, they resemble compositions of copper ore from magnet.
But there's
Criffle and other plutons in the region probably have enough data for that kind of an assessment.
mhm,
It would be interesting to do.
sure, yeah. There's quite a bit of copper near Criffle in the Black Stockton Moor
Right.
deposit. Yeah, that's more copper than gold.
Yes.
So, yeah, entirely possible. Yeah.
Kilmilford, are you aware of an igneous complex called
Oh, in Argyll.
Kilmilford?
I don't know much about it.
Okay.
Okay.
Thanks.
Thank you very much.